Okay, hi guys. So the lesson for today, we're still in section 1 of Algebra Nation, and it's learning to do transformation of graphs. So I'm going to cover this up for a minute. You do not need to write this. So we're going to learn to take graphs, for example, a parabola. That's called the parent graph. The parent graph starts, usually all parent graphs start at the origin, and we're going to learn the parent graph points today. That's all we're going to learn. And eventually we're going to learn how to shift them, and then we're going to learn how to reflect them, which means turn them upside down and stretch them or compress them. But today we're just going to learn about the parent graph points. So on your sheet that I've already posted, this is not on there, so hopefully you'll have a time to get that and write these abbreviations. If not, you can look back at the video and add them. I'm going to start off with just the parent graph points. They're called parent graph points because almost every graph starts at the origin. And this is a graph that has not been stretched, and that means that, like, if you yawn and stretch, you lift your hands up really high, or compressed where you flattened it, it has been flipped upside down. It's just a normal graph that just has its normal points. So we're going to start out with the linear graph. It's y equals x. And so they're given your x's, and whatever your x's are, that's what your y is. So if I start out, if x equals -2, y equals -2. If x equals -1, y equals -1, because y equals x. So this one's real easy to do, and it's called linear because the root word is line. So if I do these points, and hopefully I don't mess this up because I can't start over, and I already did. First off the bat. Okay, so boy, I need my S check. Start here, that's -2, 2, so we're going to forget that. Let me do a different color. I'm not starting over. -1, 1, 0, 0, 1, 1, and then 2, 2. And then we draw a straight line. Hopefully this is straight. My thumb hurts when I pinch it. Ouch. Okay, and that pin's going. So that's linear. Okay, that's linear without that pink dot. Okay, so then I'm going to go back and do this towards the end. Domain, range, increasing and decreasing in years. So that's the parent graph right there. Just right through the origin, that's our parent graph. And of course you can see the slope is just up 1 over 1. So that's a linear. Okay, so let's go do quadratic. This is the one that in Algebra 2 first semester we're going to spend so much of our time on. So these are the parent graph points you're going to have to really know. So here, to find the y value, which also remember can be used like this, f of x or g of x, you just take the x value and you square it. Whenever you square a negative, it forever becomes a positive. So -2 squared is 4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. Look at these. They're exactly the same here. So when I graph this parent graph function, let's see if I can see this better. Ooh, this is even worse. 0, 0, 1, 1, 2, 4. And then one thing about quadratics, they just reflect. So I can kind of see this one a little bit better without doing the points. So you remember this one, guys? This is called an even function because it's symmetric over the y-axis. And that's your quadratic right there. Doesn't look very symmetric to me, but it is if you could graph better. So maybe your points will be better than mine, but I can't get right in front of it because of the camera. So there's your parent graph points for a quadratic. All I'm doing is taking the x value, substituting m to find the y value. Then we'll go to cubic. So cubic, notice, look at these. These are all the same. And by the way, you can take any x value you want to, but since it's parent graph points, you want to always take numbers that start around the 0 because, again, parent graph points, almost all of them go through the origin. So you want to take x values close to the origin if you can. So here, I'm going to use these x values, and I'm going to cube them. Now, when you cube a negative, remember what I said about when we were learning negatives and the exponent is odd, it's going to stay negative. So when I take -2 cubed, it's -8 because -2 times -2 times -2 is -8. -1 cubed is -1. 0 cubed is just 0. 0 to the 100th is 0. 1 cubed is 1. 2 cubed is 8. Huh, look at that. They're just opposite signs. So then when I plot these parent graph points, and sorry about the little scribble scrabble there, this is going to be 0, 0, see how it goes to the origin, and then -2, -8, -2, -8. Ooh, let's hope I can see this point. I think it's close to here. -1, -1, 0, 0, 1, 1, and then 2, 8. Now, that looks like a straight line. Sure looks like one to me. But on cubics, it's kind of curvy. So you don't want to go straight. Okay, this is going to be hard without me getting in the camera. So you want to go like curvy through the points. And this does go to the right, and this does go to the left. If we could do more points, you would see, like if I did 3 and go on, 3 cubed is, oh my gosh, 27. So you could see that we still would go right and then up more. So there's the parent graphs for cubes. So then we go to absolute value. Now I don't know if you recall this from Algebra 1, but absolute value makes everything positive. Absolute value makes everything positive. You need to write yourself a little note. Absolute value makes everything positive. Write yourself a note so you remember this. Absolute value makes all your x values positive. Let me check the time. Can't really see it. Okay, so the absolute value of -2 would be 2. The absolute value of -1 would be 1. The absolute value of 0 is 0. Absolute value of a positive stays a positive. And 2, 2. These are actually my favorite ones to graph. So they make a V shape, and I always say peace out when I say what's the peace out graph. That's absolute value. So when I go -2, 2, that's up here, -1, 1, 0, 0, look, we're at the origin again, 1, 1, and 2, 2. And then when I make sure you put arrows, I actually will mark you off the test or quiz if you don't put arrows, because these do go on forever. And there you go, absolute value. So far, 1, 2, 3, 4 graphs I've used the same order pair, the same x values, the same x values for my parent graph. Come to the first one, I can't use the same x values because the original function is the square root of x. Well, so now I gotta look for perfect squares. Now this worksheet gave you the square root of -9 and the square root of 4. Well, we can't take the square root of -9. We can't take the square root of 4. It gives you an error in your calculator. So they were just throwing that in because that's an error, so we can't use those. So the reason we don't use -2, -1 is because we can't square root them. Now we can square root 0. Square root of 0 is 0. We can square root 1. The square root of 1 is 1. You could use 2, but it's a nasty decimal number, so we don't like to use those. We want things that look pretty. So I'm going to use the square root of 4 because it's a perfect square. It's 2. And then I'm going to use the square root of 9 because it's another perfect square. It's 3. So when you graph this one, we start at 0, 0. Again, it starts at the origin. And then we go 1, 1. And then we go 4, 2. 1, 2, 3, 4, 2. And then we go 9, 3, 9, 3. And then we connect the dots. Now, I know this is silly and you can't see me, but I call this my hello graph. Hello, because it's waving at you. Hello, like that. So I'm going to come around so I can see how I'm doing on time. I can't see from the side that I'm on while you are still copying, because I know you guys are going, man, she's going super fast. Got to kind of move my camera. Okay. Can only go so long. This one I'm saving. We're going to do a whole section just on exponential. I'm going to do it at the end for the honors kids and have them know it. Periods 1 and my other periods, we're going to like save that for later. Okay, and I am going to pause this video for when we're in class so you guys can ask me questions. But right now you can just rewind and see the video. So that's what every parent graph looks like before we do things to it. We can flip these over, we can stretch them, we can shift them, but that's the parent graph points right there in a nutshell. Now let's talk about their domain and ranges real quick. So domain here, let's go back to the linear. Domain, remember how far left and right they go? Well, this one goes forever left and forever right, so this would be negative infinity to positive infinity, forever left and right. The range, well, this goes forever down and forever up, so that would also be negative infinity to positive infinity. Remember, you go down to up on ranges. Again, if some of you have forgotten, your domains are your x's, your ranges are your y's. Okay, increasing interval. Well, the whole thing increases. It increases forever. It doesn't decrease at all, so there is no decreasing. And what's my x values? Well, it increases from left to right. Well, what's your x way over here? Your x is negative infinity to what's your other x over here? Positive infinity. So look at this. That's your answer for increasing interval. It increases from negative infinity all the way to positive infinity. So there's your answer for that one. Okay, let's try this one. Okay, so domain. Well, I know it doesn't look like it, but your parabola will get wider and wider and wider like this. So what are your x values if I have arrows and they go forever to the left and forever to the right? So forever left and forever right, that would be negative infinity to positive infinity. Okay, for your range, well, again, it's from the least to the greatest. So what's the lowest value on this one? Well, the lowest value I see right here is 0, and then it goes up forever. So if I start at 0, it goes up forever. This would be 0 to positive infinity. Now I see a decrease, and then it increases. So what's your x value right here? Your x value is 0, and then what's your x value to the right? So it starts at 0, and then it increases forever. 0 to forever. 0 to forever. So it's increasing from 0 to positive infinity. And remember, you don't have to think about increasing and decreasing. It's always parentheses on increasing and decreasing intervals. Think about being on that roller coaster. If you're just sitting there, you're neither increasing or decreasing. Okay, so decreasing, well, it decreases from here. What's your x value here if it's left? So if you're left, that would be a negative infinity. And then if you're on that roller coaster and you're going down and you stop right here, you stop at, what's the x value here? At 0, and you're just sitting there, you're not doing anything. So it'd be 0 parenthesis. 0 parenthesis. Okay, how am I doing on time? Gotta check the time again. Okay, I think I got time for one more, and then I'm going to stop, and I want you to try the other two by yourself. So domain here. I'm going to do this one because it looks like it's just going down and up. But remember, it is going to a little bit to the left and a little bit to the right. So hopefully you know this is negative infinity to positive. It's definitely going down forever and up forever, so that's negative infinity to positive. Okay, this one's kind of like this one, isn't it? So it's only increasing. It's not decreasing at all. It's just going up. It's just continually going up. So this one would be the same as this one. Negative infinity to positive infinity, and there is no decreasing interval. So I'm going to have you try to finish these. Hopefully you do it in pencil. And then this one I'm going to talk about in class. Okay, so that's it for the video for now. Goodbye.